Ethers are named by giving the alkyl groups in front of the suffix ether. If the alkyl groups are different, they would be given in alphabetical order. If they're identical, then we use the prefix di in front of the alkyl groups. As an example, diethyl ether contains 2 ethyl groups. In the next example, we have a methyl and an isopropyl group. If we alphabetize those 2 groups, they would be isopropyl, methyl, followed by the suffix ether. Note that in isopropyl, we use the letter I from the prefix. Most prefixes in naming are ignored when it comes to alphabetizing. So prefixes such as di, tri, tetra, or sec are typically ignored. In the next example, we have an ethyl group and a phenyl group. If we alphabetize those 2 groups, we have ethyl, phenyl, ether. And then on this last example, we have an allyl group on the left and a vinyl group on the right. If we alphabetize those 2, we have allyl, vinyl, ether. Occasionally, an ether group would be attached to a molecule that contains another functional group. And so we would name the ether group as a substituent using the names methoxy, ethoxy, propoxy, or other names. As an example, here we have 2 methoxy groups on a benzene compound. So we name this as para-dimethoxybenzene. We could also name it as 1,4-dimethoxybenzene. In this last example, we have a terbutoxide group attached to the 4th carbon of this cyclohexene. Note that the double bond is numbered on carbons 1 and 2. That always should be the case. And if we continue in the direction towards the terbutoxide group, the terbutoxide group is on the 4th carbon. To name thiols, we typically give the alkane name followed by the suffix thiol. As an example, we have here ethane thiol. Next, we have cyclohexane thiol. In this next example, we have a thiol group and an ethyl group that are cis to each other on a cyclobutane. So this compound is named as cis-3-ethyl cyclobutane thiol. On the last example, on the top here, we have a thiol that is on a 1, 2, 3, 4 carbon chain. So that would be a butane 1-thiol, since the thiol is on the 1st carbon on the right. If we continue counting, the fluorine is on the 3rd carbon, so this is named as 3-fluorobutane 1-thiol. Occasionally, we might need to give the sulfohydryl group as a substituent on a molecule that has another functional group with higher priority. Here is an example. We have this thiol group on the 3rd carbon from the carboxylic acid. Since these are the only 2 substituents on this benzene, we could also name it with the prefix meta or M. So this compound is named as meta-mercaptobenzoic acid. We could also name it as 3-mercaptobenzoic acid. Sulfides are named very similarly to ethers. We give the alkyl groups in alphabetical order, followed by the suffix sulfide. If the 2 groups are identical, we would use the term or the prefix di. As an example, we have here dimethyl sulfide. In the next example, we have a methyl group and a phenyl group. Alphabetizing those 2 groups we would name this as methyl phenyl sulfide. If we are going to give the sulfide as a substituent, we can use the term methyl thiol or ethyl thiol, and so on. As an example, we have here a methyl thiol on the third carbon of the cyclohexene. Note again that the double bond carbons have to be on carbon 1 and 2. If we number it in this direction as shown, we would come up with the sulfide being attached to carbon 3. As a result, we name this as 3-methylthiol cyclohexene. In this question, we're going to try to name this ether. Notice we have two isopropyl groups attached to the oxygen. This ether is named as diisopropyl ether since it has two identical isopropyl substituents on the oxygen. In this question, we have a cyclohexane that has both an alcohol and a sulfide. Alcohols are a higher priority group than sulfides, so this compound is named as a cyclohexanol with an ethyl thiol substituent. Notice it is on the third carbon from the alcohol, so this is named as 3-ethyl thiol cyclohexane 1-ol.